Continuing on with section 3.2 synthetic division, problem number 4 says to use synthetic when you're dividing 4r cubed plus 16r squared plus 9r minus 16 all divided by r plus 3. Now this one is set up fine, there's no missing exponents, so we can start the setup with a number that goes in the box. Since we're dividing by r plus 3, the minus 3 is what goes in the box. And then we're looking at the coefficients for positive 16, positive 9, and a negative 16. So we're going to set up those for 16, positive 9, and a negative 16. That's our setup. We leave that blank. The number next to the number in the box, the first coefficient, you always bring the first coefficient down. Anything below the line, you're going to multiply by the number in the box. So it's going to be 4 times negative 3 is negative 12. Add the numbers above the line. 16 and negative 12 is 4. 4 times negative 3, that's negative 12. 9 and negative 12 is negative 3. Negative 3 times negative 3 is a positive 9. Negative 16 plus 9 is a negative 7. Remember that last number is always your remainder. So the way you set up the answer is first determine the power. In the beginning we had an r to the third divided by an r to the first, so our answer is going to have an r to the second power, using 4 as the first coefficient. 4r to the second power plus 4r minus 3, and then the remainder is going to be a minus 7 over what we divided by in the beginning, which was r plus 3. So we have 4r squared plus 4r minus 3 minus 7 over r plus 3. Okay, it looks like choice D is the correct answer for mine. Let's look at question number 5. For question number 5, we want to use synthetic division to divide. But this problem is missing some powers exponents in the numerator. So I'm going to write this as x to the third power. We are missing an x to the second power, so I'm going to put plus 0, x to the second power. We're also missing an x to the first power, so I'm going to write this as 0, x to the first power minus 8. So you want to make sure you have all of those powers of x, and you're going to divide by x minus 2. So our setup becomes a number in the box. Since we're dividing by x minus 2, a positive 2 goes in the box. And then we're looking at the coefficients, 1, 0, 0, and negative 8. 1, 0, 0, negative 8. And now you do the synthetic division. Remember to always bring down that first coefficient and multiply whatever's under the line by the number in the box. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. 0 plus 4 is 4. And 4 times 2 is a positive 8. Negative 8 and a positive 8 give you 0. That last number, that's your remainder. This remainder is 0, so it goes in evenly. Our answer, we start off with an x to the third power. We divide by an x to the first power, so an x to the second power is going to be our answer. 1x to the second power plus 2x plus 4. Of course, you don't need that 1 coefficient. You can write it as x squared plus 2x plus 4. We can check our answer. Looking at question number 6. Use synthetic division. This is similar to the one we just did. because it's missing a lot of exponents. So the first thing I'm going to do is rewrite the numerator so that you have all of those missing powers of x. Start with an x to the fifth, so we need a 0 x to the fourth, a 0 x to the third, a 0 x to the second, and a 0 x, and then finally the plus 243, all divided by x plus 3. So in our setup, we're going to put a negative 3 in the box. Dividing by x plus 3, you put a minus 3 in the box. Then you're going to look at the coefficients, starting off with 1, 0, 0, 0, 0, and 243. We're missing that 1, 2, 3, 4 powers of x, so you want to have those 4 zeros in the setup for synthetic division. Always bring down the first term to get 1. The first coefficient, 1 times negative 3, 0 plus negative 3 is negative 3. Negative 3 times negative 3 is a positive 9. 0 plus 9 is 9. 9 times negative 3 is negative 27. 0 plus negative 27 is negative 27. Negative 27 times a negative 3 is a positive 81. 0 plus 81 is 81. And 81 times negative 3, that is negative 243. When you add those, the last number is 0. Our remainder is 0, so this divides in evenly. So the way we write our answer, again, we start off with an x to the fifth dividing by x to the first. So this is going to be 1x to the fourth power. The leading exponent is x to the fourth power, minus 3x to the third power, plus 9x to the second power, minus 27x plus 81 with a remainder of 0. Now we don't need that 1 in front, so we can write our answer as x to the fourth power minus 3x to the third power plus 9x squared minus 27x plus 81. Okay, so for these problems, you want to make sure you put any zeros if you're missing any powers of x. All right, for question number 7, we're asked to use synthetic division to decide whether the given number, let me repeat that, use synthetic division to decide whether the given number k is a zero of the polynomial function. All right, the way you do this with synthetic division is you are going to set up synthetic division, and if the given number k is 3, you're going to put a 3 in the box. And then you're going to use the coefficients of the polynomial function. The polynomial function is 1, negative 7, and a positive 12. Now when you do the synthetic division, if the remainder is 0, then, if the remainder is 0 equals 0, then we can say the given number k is a 0. Then k is a 0, and we'll get into what that means for a number to be a 0 of a function. So that's our setup. 3 goes in the box because we want to know if k equals 3 is a 0. We use the coefficients for synthetic division. Always bring down that first coefficient of 1. 1 times 3 is 3. Negative 7 and a positive 3 is a negative 4. Negative 4 times 3 is negative 12. And here we do get a remainder of 0. Since the remainder is 0, then we could say yes. 3 is a 0 of the polynomial function. Okay, let's look at number 8. Again, use synthetic division to decide whether the given number k is a zero of the polynomial function. Since we want to know if -5 is a zero, we're going to put -5 in the box for the setup for synthetic division. We're going to use the coefficients, make sure there's no missing exponents. So it's going to be 1, 7, 7, -15. Okay, always bring down that first term, 1. 1 times -5 is -5. 7 plus -5 is 2. 2 times -5 is -10. 7 plus -10 is -3. -3 times -5 is a positive 15. -15 and a positive 15 is 0. The remainder is 0, so the answer is yes. We can say -5 is a zero of the polynomial function. And we base a decision on whether or not we have a remainder of 0. Now what that means graphically, I'm going to show you what that looks like if you have a graphing calculator. Okay, with a graphing calculator, you can get a different interpretation of what it means to be a zero of a polynomial function. You can graph a polynomial function f of x equals x cubed plus 7x squared plus 7x minus 15. Remember, f of x is the same thing as y. So turn on your calculator and press y, and you're going to enter that polynomial function for y1. Now, if there's anything else on the screen, you want to clear that. So again, I've already entered the equation. And to look at the graph, I'm going to press zoom and then choose the standard zoom, which is number 6. Now, we haven't practiced graphing these, but we can say that -5 is a zero of the polynomial because that's where the graph has an x-intercept. If I press trace, you can see that this graph crosses the x-axis 1, 2, 3 times. And that can happen when you have a function which is x to the third. This crosses the x-axis 3 times, so it actually has 3 zeros of the polynomial function. And we want to know if -5 is one of those zeros. So if you graph it and you press trace, type in -5 for the x value, you'll see that that is one of the points where the graph crosses the x-axis. So we say -5 is a zero of the polynomial function. And you can probably guess by looking at the graph where some of the other zeros are. So if you did, it looks like from the graph 1, 2, 3, -3 is also a zero of the polynomial function. So I'm going to type in -3. You see when you get -3 for the x, the y is equal to 0. That means -3 is also a zero of the polynomial function. If you use synthetic, you would get a remainder of 0 if you put a -3 in the box. And it looks like a positive 1 is a 0. So again, you can trace and type in 1, and you'll see that this graph also crosses through the x-axis at positive 1. If you did synthetic with a positive 1, then you would have a remainder of 0.